Dave Water mentioned that predicting the future is a magic, is artificial intelligence. Assalamualaikum Menhat. My name is Muhammad Haikal Othman from Universiti Teknologi Malaysia UTM. Today I will be presenting my project together with poster that have been supervised by Professor Dr. Karya Muhammad Yusof and Ms. Nur Syuhada Ali. My project title is Neural Network Predictive Model for Refined Palm Oil Quality Soft Sensor. There are a variety of products that may be made from palm oils, including baby's milk, margarine, chocolate, and other similar items. The refinery process is required in order to manufacture such things, since the palm oils must be refined first. In the refinery process, there are three main unit operations, which are the degumming, bleaching, and deodorization process. And the final product is refined, bleached, and deodorized palm oil, or we call as RBDPO. Currently, the RBDPO will be sent to the lab and testing, and the time it takes to receive the result is quite lengthy and expensive because it requires the preparation of chemicals as well as the purchase of specialized equipment to conduct the testing process, and might also involve many human errors through the process. For this project, we want to achieve several objectives, which are the first one is to develop artificial neural network in order to forecast the quality of our BDPO. The neural network model must be trained with a large amount of data in order to produce an appropriate neural network model. As a training technique, we use Level Marquardt. After we develop the system, we will test its performance and identify the best set of data distribution by using the actual data provided from two palm oil refinery plants, which are Nuri refinery plant and also Lahad Datu refinery plant. To complete this project, firstly we need to understand the whole process of palm oil refinery process. Then we select several inputs and output that can play important role for quality of BDPO. Then we proceed to collect the data and distribute them into four cases. After that, we develop the single NN model and continue with network simulation that cover FFA, color, and IV quality. Finally, we compare the result and performance from the model network with actual data from refinery plant. When it comes to the performance of neural network model, the root mean square error RMSE and regression R squared value is used to measure the performance. The lower the RMSE and the higher the R squared value, the better performance of the AN network. We have prepared for different set of data distribution, which case one is the original set of data given by Nuri refinery plant that have 309 of data, while case two is set of data that have used only 100 data and have only included minimum and maximum value for each variable from case one. Move to the case three is a bit different because some value of input bleaching a dosage have been edited, which increase almost 50% from the original value because of their FFA input quality is exceed 4.5. Lastly, case 4 is set of data that combine two refinery plant and the total is 1675 data. Then each case of data collection is separated into three halves, one for training, testing, and one for validation data. Based on the result calculated that shown in our MSE figure, we can conclude that the performance of network model in case 1, 2, and 3 is poor, with the exception of case 4 because case 4 is recorded the lowest root mean square error RMSE value when compared to the others. As a result, it demonstrates that all the network model is well trained. However, a good network model will have a correlation coefficient R squared that is close to 1. The R squared for the FFA and color network models for data case 2 has the greatest value when compared to the other models, while for the IV network model, the maximum value of R squared is recorded from data case 4. So, for the conclusion, an NN network is used in this project to predict the quality of refined degummed bleached palm oil (RBDPO) from two distant plant palm oil refineries and to compare the performance of the model using four different data distribution method has been developed successfully. Based on the result created, RMSE and R-squared training, testing, and validation network for all cases, with the exception of case 4, are deemed to be insufficient. This is due to the fact that the value of RMSE and R-squared that were obtained are not close to 0 and 1, respectively, as a result of several errors that occur during the selection of the data for training and testing data, in which there was a repetitive data utilized occurred. The repetitive data that was utilized will result in the model being overfitted, and also this is due to the fact there is no variety in the data and may have an impact to on the performance of the network model. Some recommendations that I want to highlight here are: first, add more training data so the model will be able to learn through experiences and example. Furthermore, selection of data for training and testing should be done properly and wisely. Last but not least, collection of data must be precise and carefully to reduce any human mistake. I think that's all from me. Thank you.